Hello and welcome to this MOOC. I'm Claudia. I'm working at the Remote Sensing Laboratories at the University of Zurich for the National Point of Contact, and I'm here to introduce you in the details of the Copernicus program, Europe's Eyes on Earth. So the program is designed to look at our planet and its environment for the benefit of Europe's citizens. The Copernicus program is based on three main pillars. So on one side, we have the so-called in situ data, which are data taken from the ground, used for calibration or adding additional measurements to other observations, such as ground stations from weather stations or sensors deployed in the ocean, or even taken, for instance, from a drone to create an image. On the other side, we have the service components. The service components are so-called higher level products, which have a lot of information than just what you can see within a map. These so-called value-added products are categorized in these six categories of activities of the Copernicus program. We, however, within this talk, will focus on the space component. The core of the space component of the Copernicus program is the so-called Sentinel family. The Sentinel family is developed and operated by ESA, the European Space Agency, where Switzerland is also part of. The Sentinel fleet or Sentinel family contains a variety of different satellites who measure the Earth in a different way, and they're tailored to the needs of the Copernicus program. Within this talk, I will mainly focus on Sentinel-2, which is actually the satellite that is most easiest to understand for us because it's similar to a camera in a cell phone. However, it can more than just taking picture in red, green, blue. When you're working with satellite data or when you want to make an application with satellite images, then you need first to ask you some basic questions. So the first question is, what process do you want to see? And depending on this process, you're going to choose the data source. The different satellites are characterized by different spatial resolution, spectral resolutions, and the so-called temporal resolutions. I will give you some insight in the next slides on these questions. And fourth but not last, you need also to consider what platform you can and want to use for the processing itself. The first decision we have to reflect on is the spatial resolution. Spatial resolution means, in our understanding, the size of one pixel on the ground. So at the top left, you see, for instance, the resolution with a 1 meter commercial satellite. So nowadays, the satellites can measure below a meter in resolution. At the bottom, you see the data we are usually working with, which is the 10-meter resolution of Sentinel-2. On the other side, you have also different satellite images with either several tenths of meter resolution or hundreds of meter resolution. Depending on your application, for instance, if you look at the continental scale or a local scale or globally, you choose the satellite of your interest. The second question you have to ask yourself is the question of the spectral resolution. And this is also very closely connected to the sensor type you're going to choose. Sentinel-2, the optical one that is working just with the emitted light from the sun and what is reflected from the Earth's surface, is recording in the visible spectrum, so down here, which means the red, green, blue channel that we are also observing with our cell phone cameras. However, where it's very powerful and where the advantage of satellite comes into play, it's recording in this entire area. So there are more than 10 channels recorded by Sentinel-2, also in the infrared range. On the other side, we have, for instance, Sentinel-1 and Sentinel-6, who are active in the microwave area. Sentinel-1 and 6, they are even active satellites, so they're sending out some radar pulses that will be reflected from the Earth's surface in order to observe different processes. Why would you be interested in using microwave and an active signal? Is that Sentinel-1 can penetrate through clouds and also is not dependent on sunlight. That means it can also measure during night when there is no sunshine. In order to give you a better understanding what I mean with using different bands and what it can show you additionally, here is an example of a Sentinel-2 image of the Vesuvio in Italy in July 2017. You can see here Naples, the city up here, and the one who know the region, this is the Vesuvio, the volcano. Most or some of you might know Vesuvio is not active currently, but there is still a lot of smoke. So the question is, where does this smoke come from? Looking now at not a red, green, blue image, but at the image using the infrared channels, so shortwave infrared 1 and 2, and the near infrared, you can suddenly see a lot more details around the volcano. So the smoke is disappeared, and you see some fire fronts from a wildfire on the slopes of Vesuvio, the volcano. The next question you have to ask yourself is, what temporal resolution do you need? So the revisit time, that means how often do you need a new picture of the area of your interest. What you can see here are Sentinel-A, 2A and Sentinel-2B orbiting in tandem around the Earth and taking pictures from everywhere. And after exactly 5 days, you have the entire globe covered with the 2 satellites. So if we zoom in, however, into Europe, you can even see that Europe gets an overflight and a picture about every 3 days. So in conclusion, you get every 5 days a picture over the equator, and in our areas about every 3 days. Now we heard a lot about capabilities that the Sentinel satellites have. However, so what is new with this Sentinel family is actually that they provide a very high quality and reliable product continuously all the time, every 5 days or every 3 days, depending on the satellites, and on a long-term basis. Long-term basis means it's scheduled for even more than 30 years. And what is even more important, the data is so-called analysis ready. So the data you can get is, for instance, in the so-called level 2, is already corrected for clouds detection or for the atmosphere or georeference. So you can just take the images without knowing exactly how the instrument on a satellite is working. And last but not least, everything is free and open. Even if you are not part of the Copernicus program, Switzerland is unfortunately not yet part of it, you can get the data even for commercial use on a global scale. Now you might be very eager to discover the satellite data by yourself. So as a first step, I would highly recommend you to go on a browser-based solution, such as the EO browser, where you can just browse and discover the satellite data by yourself. Or if you're interested in the original data, you can go to Sci-Hub and download all the images from the different satellites directly. As a second step, you can then use a normal GIS software, as all images are georeferenced, for instance, the open source software QGIS, or you can also use softwares like the Snap, which is the software made for having different processing toolboxes on top for the different Sentinel satellites. If you know already that you're going to process a large amount of data, you can also consider directly the cloud solutions such as the DIASes, which are part of the Copernicus program, or you go into the commercial cloud processing platforms such as the Amazon Cloud or the Microsoft Planetary Computer or the Google Earth Engine for an easy processing of the satellite data. Last but not least, you can for sure also use all normal programming softwares where, for instance, Python and R also have toolboxes to process this different type of data. With that, I just want to highlight, if you're interested in more applications, watch out for the lecture or the MOOC on EO for Society. Otherwise, from my side, just thanks a lot for your attention. And if you have more questions about how to use the satellite data, contact us via email. We are here for any Swiss entity in Switzerland to help dealing with the satellite data. Thank you.